All right, so the second part of the lab is going to deal with inclined planes. That's why I said there's two parts to this lab. Now, listen to me. Focus, everyone, focus. These are two distinct, separate labs. Nary the two shall meet. I don't want diagrams on the same piece of paper, one for the hanging sign lab, one for the incline lab. These are two completely separate labs, okay? I don't want them stapled, the two labs stapled together. You treat these as two completely separate entities. You keep them completely separated, okay?
Segregated.
So, here's the story. The first part of the inclined plane lab, which is that blue sheet, you're going to try and find the coefficient of static friction. So, this is a classic example of me applying a force, but what's the acceleration?
0.
0. Because the frictional mafia is trying to get it to slide down. Excuse me, the gravity mafia is trying to get it to slide down, but the frictional mafia is holding it in place. Now, as I lift this up, eventually what's going to happen?
Acceleration.
It's going to begin to slide. It's going to break loose. So what we're going to do on this, at that point where it just begins to slide, so you've got to lift it up slowly and find that point that it just begins to slide. So I've got my forced parallel acting down and the frictional mafia holding it in place. So what we're going to do is we're going to assume at that point where you lift it up and it, bam, just breaks loose and begins to slide. You know that mu equals force friction over force normal. True? You've seen this, not rocket science. Now, we're going to assume that the force friction is just being bounced out by the force parallel. So we're going to put that as force parallel over force normal. Now, Sean, how do you calculate force parallel?
FG sine.
Theta. And normal is FG
Cosine.
cosine theta. FG's cancels out. This is your one chance. This is your one chance to use trig identities outside of a math class. Do not blow it. Sine over cosine is
Tangent!
tangent.
Yeah! My guess from yesterday.
Yes! Now, E equals tangent theta. Now, listen to me and listen to me closely. That only works for static friction. Okay? Doesn't work for kinetic friction. It only works for static friction. So what you're going to do is you're going to take a block, put it on there, lift it up, and you're going to find that point where it just begins to slide. Now, obviously, if I did that with a golf ball, what's going to happen?
Go start rolling like immediately.
Yeah, I mean, I lift this up kind of anything at all. So what do you know about the coefficient of static friction on round objects versus the block?
They're less.
Much, much less. Okay. Coefficient of static friction. That is one part of the inclined plane lab. It has nothing to do with the next part. Okay? Completely separate even within this lab. Next thing you do is you're going to take a block and you're going to set this thing at exactly 30 degrees. Okay? You're going to set it at 30 degrees. This has nothing to do with static friction. Static friction has left the building. So you're going to take a block and you're going to pull it up at a constant velocity. So what are the two most important words in what I just said?
Constant velocity.
Constant velocity. So you're going to have this thing set at 30 degrees, and you're going to pull this thing up at a constant velocity. Now, when you do that, what are you measuring? Force applied, force parallel, or force friction?
Force
applied.
You're measuring the force applied, okay? You're measuring the force applied.
Then you gotta subtract force friction.
Oh, because what you're after is force applied. You're going to have your FG, your force normal, Now, if it was a frictionless surface, what would be the relationship between force applied and force parallel?
The same.
There'd be the same value but opposite signs, right? If there was. So let's say that my applied force was 3 newtons. It took me 3 newtons to pull this thing up at an inclined plane at a constant velocity. You're at a 30-degree angle. If you know the weight of the block, how are you going to find the weight of the block, by the way?
Hanging from the scale.
Hanging from the scale. You're going to know this number. You can calculate your force parallel. Okay? So let's say, for example, the force parallel was negative 2 newtons. So if my force applied is 3, and my force parallel is negative 2, what's the value of my frictional force?
-1,
Why?
because force friction plus force parallel is force applied.
Yes, because both of these are acting down the inclined plane. So you never directly measure force friction. What you do is you measure how much force it takes to pull it. Now, if you're on a flat surface, there is no force parallel. Your applied force is just balancing out your force friction. But because you're on an inclined plane, your applied force going up has to balance out 2 things. So what you're after on this blue sheet, okay? So notice up here, capitals, bolded, underlined, show all calculations, even in a different font, okay?
I'll even put little stars next to it.
Would it be possible to do italicized as well?
No, don't push it. So you're going to have the static friction. Lift it up, measure the angle, boom, that's all you got. On the sliding friction, I don't care how you define your system. Do you want downhill to be positive or negative? Don't care. Pick a number. But once you define it, and you guys collectively don't even have to keep that same system. If Danny wants to do negative downhill and Sean wants to make downhill positive, hey, cool. Okay? Doesn't have to be within the same group. So, on another sheet of paper or on the back of this, you're going to draw a free body diagram showing all the forces involved drawn to the correct scale. This one is not a sketch, okay? This is drawn to a scale. You're going to draw a 30-degree angle. You're going to go, oh, here's my gravitational force. Normal, whatever you think there are. Then you're going to calculate your force parallel, your normal, your force friction. What you're ultimately after is mu. Then you got some questions to answer there. So this is going to be one diagram, okay, for the 30 degree. Not for the static, only for the kinetic at 30 degrees. On this one, the yellow, the purple line, this is one where you're going to set the scales and hang the string in between. So, bold, underline, show all work for the calculations, okay? Because everybody's data is going to be different. So, what you want to do here, down here on number 3, and again, you're only going to do this for the first trial. You're not going to do it for the second trial, only do it for the first trial. You're going to show, it's going to look something like this. You're going to have your 2 tensions. You're going to break those up into X and Y. Break that. And then you're going to have that negative 9.8 Newton force acting down. What you're trying to prove is, are these 2 X components the same numeric value but opposite direction? Are these 2 Y components, do these add up to negative 9.8? All right, I'm done. Get your data. Be free.
We all agree to make downhill negative and uphill positive.
Yeah.
All right, stop the camera.